Okay, this is the video for angles of elevation and depression. So the angle of elevation is the angle in which your line of sight changes as you raise your eyes to see something above you. So if like you were standing here and you were looking to the top of the tree, or whatever this object is, this is a tree, then this right here is your angle of elevation. And your angle of depression is similar, except it's when you're looking down. So as you lower your eyes to see something that's below you. They are congruent, same as how if you were to draw two parallel lines here. So like you've got this lookout tower in the plane. So if we draw these lines and you cross it with this transversal, cut it with this transversal, your angle of depression is here and your angle of elevation is here. So they would be congruent, same as how alternate interior angles are congruent when you have a parallel lines cut by transversal. Okay, so this is just another picture to show you. So if this person's standing up on a balcony or whatever this is and looking down at this person standing on the ground, then there is the angle that they're looking down at is the angle of depression, and then the angle that this person's looking up at is the angle of elevation. And again, they would be congruent because these two lines are parallel, so they're alternate interior angles. Okay, so we want to actually do a couple problems here. So from a point, and I'm going to use the picture here since how it looks way nicer than what I would draw. So from a point P, 10 meters from the base of a flagpole. Okay, so here's your flagpole, and you're out here at point P, and this is 10 meters. The angle of elevation is 50, so this is 50 degrees. That's the angle of elevation. And you want to find the height of the flagpole, so you're looking for H. So if you knew the distance from the top of the flagpole to this point, you could use Pythagorean theorem, but since all you know is the angle of elevation and this, then you're going to use sine, cosine, or tangent. So you have to figure out which one that is. So last week, you should have watched the video on sine, cosine, and tangent. So you have to figure out which one you need to use. So I just called the height of the flagpole H, okay? So if you're looking from this angle here, you have to know, I'll just write it down up here real quick. You got sine, cosine, and tangent. So I'm trying to think. I remember it by saying orange horses always have orange ankles, but there's another one that I've forgotten right now that other people use. So orange horses, so this would be opposite over hypotenuse. So orange horses always have, so adjacent over hypotenuse, orange ankles, so opposite over adjacent. So there's another one that's left me. It'll come back to me eventually, I guess. But so that's how I remember these. Orange horses always have orange ankles. So if you're at this angle right here, then you have over here, this is the opposite side. Of course, the hypotenuse is always this long side here that's opposite your right angle. So here's your right angle, right? So this is always your hypotenuse. So I'll just label it for you. So the biggest part that people get confused is whether you've got an opposite or adjacent. So if you're at this angle, this is your opposite side, this is your adjacent side. If you're up here at this angle, this is your opposite side, this is your adjacent side. And the hypotenuse is always opposite your right angle. Okay, so we're standing here at this point P, and this is our angle of elevation. So we have the opposite side and the adjacent side that we're talking about. So if you're talking about opposite and adjacent, we don't know anything about the hypotenuse, you're dealing with tangent. So the tangent of 50 degrees, that's our angle of elevation, has to equal what we said here, opposite over adjacent. So opposite would be H over my adjacent would be 10. And then all you want to do is solve this equation. So to get rid of division by 10, I'm going to multiply by 10 on both sides. So I have 10 times the tangent of 50 degrees is equal to H. And then you can do that on the calculator. So if you go, my calculator's on my computer. I think I've got one somewhere, but I think it's dead. No, it cut off on me. So if I go here And I need to make sure, since it's in, it gives it to me in degrees, I need to make sure my calculator is in degree mode. So if I click mode and go down, you see radian and degree. We want degree right now, we're dealing with degrees. And then hit second mode to quit. So I'm gonna type in 10 times the tangent of 50, and it'll be in 50 degrees, and is how I just told it to do degree mode. And it'll tell me that H is 11 point, I rounded to 2 decimals, so H is equal to 11.92 meters in this case. So your height of your flagpole is 11.92 meters. Okay, so the biggest thing on these generally is if you don't have a picture, draw a picture, because that's helpful. And then deciding, based off the information here, deciding whether you're talking about sine, cosine, or tangent using this little rule here, the opposite side and the adjacent side and the hypotenuse. Okay, so number 2, we have a man who is 2 meters tall stands on the horizontal ground 30 meters from a tree, and the angle of elevation of the top of the tree from his eyes is 28 degrees. I don't know why my degree symbol didn't do right. Anyways, estimate the height of the tree. Okay, so here's the man. He's 2 meters tall, and from his eyes to the top of the tree, the angle of elevation is 28. That should be 28 degrees. It didn't like that degree symbol, I guess. And we're 30 meters away from the tree. So we're going to say H is the height of the tree again, right? Now this time, the angle of elevation is, because it tells you he's 2 meters tall, you can account for that. It's not going all the way to the ground. So if this is H, this part of our triangle here is H minus 2, because however tall the tree is, he's 2 meters tall. So however tall the tree is H, and then you start out 2 meters off the ground, so that would be H minus 2, whatever it is. Okay, so again, you look and see, do I have anything about the hypotenuse? This is the hypotenuse. I know nothing about it, so I can't use sine or cosine because I have to have the hypotenuse. So again, we're going to use tangent because you have over here, this is the opposite side, and here's the adjacent side. So again, we're going to do the tangent of our angle, which is 28 degrees, is equal to our opposite side. So for us, our opposite side over here is H minus 2. So it's equal to H minus 2 over our adjacent side, which is 30. Okay, and then you solve that equation. So 30, to get rid of division by 30, I multiply both sides by 30, so I'll have 30 times the tangent of 28 is equal to H minus 2. And then to get rid of a subtraction by 2, I add 2 to both sides. So I have 30 times the tangent of 28 plus 2 is equal to H. And that's just to account for his height, which is 2 meters off the ground, but the tree starts at the ground. Okay, so I can type that in on the calculator. So it's still in degree mode, it's not going to change, so I'm going to type in 30 times the tangent of 28. And I need to close the parenthesis because I'm going to add 2 on the outside. So that gives me H is equal to 17, again I rounded to 2 decimals, so 17.95 meters again. So that tree is 17.95 meters tall. Okay, for the last problem here, this is an A and B part. Okay, you have a fountain. It's located at the Fountain Hills, Arizona. The water column can reach 625 feet if the weather conditions are favorable. Suppose Ashley visits the fountain on a perfect day and her eyes are 5 feet from the ground. And so if she stands 40 feet away from the fountain, find the angle of elevation for her line of sight to the top of the spray. So you have I forgot to do the 5 feet because she's 5 feet. Her eyes are 5 feet off the ground, so that should be 620. Okay, I'll have to fix this. So you have, her eyes are 5 feet from the ground. So this here to her eyes to here is 5 feet. I didn't draw that in. And the water column should be on the ground, right? So the water column's on the ground. So if she stands 40 feet away, so she's standing here 40 feet away, find the angle of elevation for her line of sight. So this over here would be 625 to the ground, right? So let me draw this here to the ground. So the part from her line of sight would actually only be 620. So I need to fix this, I'm sorry. Because she's 5 feet from the ground. Okay, so again, you still have, you don't know anything about the hypotenuse, so you still have the opposite side and the adjacent side. So we're going to use the tangent, but this time our angle of elevation is what we are looking for. So we are going to call this x, and I'll fix these notes and change them. So we're going to have the tangent of x is equal to our opposite side, which in this case, like I said, this right here is 5. And so we start here, we get 620. So tangent of x is 620 over, so that's our opposite side, over our 40, our adjacent side. Okay, now to do the get rid of the tangent, you can't divide by the tangent, you have to do the inverse tangent. So you're going to take the inverse tangent. X is the inverse tangent, which you use just by doing second tan on your calculator. So if you look over here on the calculator, you'll see inverses. So we want to hit second tangent for inverse tangent of 620 divided by 40. So it's 86.3. It's not, doesn't really change much because you're just 5 feet off the ground, but it's 86.31 degrees. So like I said, this, I need to fix this because she's 5 feet. I just completely ignored that. I was doing it ground level, so this is 86.31. So I'll get that changed and post new notes. But anyways, can't be right all the time, I suppose. So at least I caught it now. So the angle of elevation is 86.31 degrees. And like I said, I mean, it's not like you're standing, you know, 20 feet off the ground or something like that. Well, 20, that wouldn't even make much difference. If you were 100 feet off the ground, it'd make a difference, but you're still close to the ground at 5 feet, so it shouldn't have changed that much. But anyways, if the distance from Ashley's eyes to the top of the spray is 628 feet, what is the angle of elevation and how far away is she? Okay, so if the distance from her eyes, right, so from here to here, it tells me is 628. And then this is, we're not doing 625 because she's 5 feet from the ground. So, like I said, I just ignored it on the whole problem. I didn't pay attention. So really, if she's 5 feet off the ground, then we are talking about this side over here starts at 5 feet off the ground, will be 620 instead. Okay, so then now we know something about the opposite side and we know something about the hypotenuse. So if you go back to where I wrote those down, if you know the opposite side and the hypotenuse, that is the sine. So we're going to have, this was part A, so this is part B. We're going to have the sine of x is equal to our opposite side, which is 620 because it's starting 5 feet off the ground, over our hypotenuse, which tells us it's 628. And again, you're going to use the inverse to get rid of it. You don't divide, you just use the inverse. So if you do the inverse sine, so on your calculator, just hit second sine and do 620 divided by 628. And you get 80.84. Degrees. So this should be a 20 and a 20, and we'll mark it out here so that I can fix it. 80.84 degrees. That's 80.84 degrees. Okay. So again, it's 80.84 degrees, and then you also want to know how far away is she, so you want to find D. So I think it's easier myself if you find D using the Pythagorean theorem. You can use sines, cosine, tangent to find this side, but most people prefer the Pythagorean theorem. So here's our right angle. So we have D squared, let me write it down over here, D squared, so that's one leg, plus this side squared, and again, you're starting 5 feet off the ground, so it should be 620 squared. So plus 620 squared is equal to, no, not degrees. 620 squared is equal to 628, our hypotenuse squared. So Pythagorean theorem, your two legs squared added together, can't write it either, is equal to your hypotenuse squared, right? So D squared plus 620 squared is equal to 628 squared. So D, if you solve this, you subtract this one over, so you're going to have the square root of 628 squared minus 620 squared. So you can solve it that way because you're adding here, so you subtract it over, and then to get rid of the square, you take the square root. So D is equal to the square root of 628 squared minus 620 squared. Because it's easier to type on the calculator that way. You can do it out and write it all down if you want to, but so we're going to do the square root of 628 squared. Click the square button. Oh, where are you? Not giving me a, whoops. Okay, minus, not giving me an error, 620 squared. Well, it doesn't like that button for some reason. And that is equal to 99.92. Or 99.9. So D is equal to 99 point, I've rounded everything else to 2, so I'll round to 2, 92 feet. So in that case, she is 99.92 feet away. So this is, should be a 20, that should be a 20, and this is 99.92. And so this is 99.92. So I apologize for having that wrong the first time. Like I said, I just missed, I didn't pay attention that it tells you how far I was off the ground. So I originally did it with ground level, but we need to start 5 feet off the ground. So now it's correct, and then I'll fix it and get a new one posted. So if you have any questions about the homework, it has questions like this that are similar to this, just please send me a message.